Now let us look at the third question of today's weekly contest. The third question was minimum array n. Let me explain you the question in short. We are given with two integers n and x. N denotes the number of elements in the array and x denotes the what we need to do in this question is we have to construct an array of positive integers only such that the size of the array should be equal to n, which is provided to us in the question. And the bitwise AND of all the elements of that particular array should give us the value of x. The result of the bitwise AND operations between all the elements of that array that we have constructed should be x. There is one more condition that every next element should be greater than the every previous element. That is num set at the index of I plus 1 is greater than num set at the index of y. So we have to construct an array in such a way such that we get the minimum possible value at the last index of the n. That is num set at the index of n minus 1. And we need to return that particular value. So let us understand this question with the help of an example first of all. N was given to us as 3 and x was 4. It means we have to construct an array such that the bitwise AND of all the elements should be equals to x. It means bitwise AND should all be equal to 4, as well as the size of the array should be equals to 3. So for bitwise AND of all the elements should be equal to 4, what should be the case? Whichever bit is set in x is equals to 4 should be set in all the elements in our array. Then only the resultant bitwise AND value will also give us the set bit. And whichever bit is unset in x is equals to 4 should be unset in at least one of the element in the array. Because you all know for the what happens in the bitwise AND operation is if all the bits are 1, then only the resultant is 1. If any of the bit is 0, then the resultant will give us 0. So we want the resultant should be x equals to 4. So whichever is the set bit in x is equals to 4 should be set in all the elements in an array. And whichever is the unset bit in x is equals to 4 should be unset in at least one of the element in the array. Yeah. We want the minimum value at the last index. So what we will do, the very first element of the array, we will take it as 4. See, let me explain you with the help of this. See, we want the resultant should be equals to 4. How can we represent 4 in binary? It can be represented as 0, 1, 0, 0. So this bit is a set bit. So we want in all the elements, this bit should be set. As well as the unset bits are these, that is 0th bit, first bit, and the third bit. So this should be unset in at least one of the elements. So the best thing is we take that particular x only the part of our array. If we take that particular x as a part of the array, this will ensure that one bit is unset in at least one of the element of the array, which is n equals to 4. Now we have ensured that this bit can never be 1, this bit can also never be 1, and this bit can also never be 1. Now we need to just ensure that this bit should be 1 in all the elements of the array. Now one element we have already taken, that is as 4. We want the size of the array should be 3. So we want 2 more elements. So in these 2 more elements, what can be the possible combinations? It could be 0, 1. It could be 1, 0. Yes or no? It could be either 0, 1 or it could be 1, 0. So the next element will be 5 and next element will be 6. So the array will consist of 4, 5, 6. We can easily see if I do the bitwise AND of 4, 5, 6, it will give me 4. Because this bit will remain unset, this bit will remain set, this bit will also remain unset, and this bit will also remain unset. So my resultant will give me 6 only. If the size of the array would have been 4, then the combinations would have been 4, 5, 6, 7. So let me explain you with the help of code now. In the code, you can see what we did is, 1 second. In the code, what we did is, we have taken one variable answer, which we need to return at the end. Why we have taken the long variable? Because you can see the constraints. The constraints were till 10 raised to the power 8, which were specified in the question. X is less than equal to 10 raised to the power 8, as well as n is also less than equals to 10 raised to the power 8. So suppose if x is equals to 10 raised to the power 8 and n is also equals to 10 raised to the power 8, then the limit should be then the data type should be long, right? Because integer can hold only up to 2 raised to the power 31, which is approximately equals to 10 raised to the power 9. So that is why we have taken it as long. We have defined one more vector, vector long v. What will this vector help us to do? This vector will help us to store the unset bits in x. So for int I equals to 0 and less than 64, we are iterating through all the bits of x, I plus plus. If not equal to x and 1 lesser than I, what is this condition doing? If x and this condition is true, it means that particular bit is set. We have applied the not equal to operator. It means if that bit is unset, then we are going to push back into our vector. I will do the dry run, understand it once. So all the unset bits in x are in the vector v. Then I have decremented the value of n. Why I have decremented the value of n? Because if n is equals to 4. So first element of the array, we have already taken it x. So now we want only 3 more elements, right? So that is why we have decremented the value of n. So now we want just 3 elements. So what is the bitwise representation of 3? Bitwise representation of n. If any particular bit is set in that, so we are going to raise to that bit will contribute 2 raised to the power I. Obviously, if see in this particular image, if this particular bit is set, right? So this particular bit is contributing 2 raised to the power 2. This particular bit is contributing 2 raised to the power 0, and so on. In the similar way, if I want the binary representation of n, and if that particular bit is set, so it will raise to the power 2 raised to the power n. And at the end, we are going to return answer. Let us see with the help of this image. The very first element 4 was 0, 1, 0, 0. N is given to us as 3. And the first element we have taken as 4 only. Now n becomes 2. What is the binary representation of 2? The binary representation of 2 is 1 and 0. So the first bit is unset. So it means this condition will become false. If n and this 1 lesser than I. This will become true if the bit is set. So first 0th bit is unset in 2. So this condition will become false. Nothing will happen. It will go to the first bit. That bit is set. Binary representation of it is 1 and 0. That particular bit is set. So what will happen? It will contribute 2 raised to the power I. In the vector, we have stored the unset bits. So 0, 1, and 3 was gets stored. So 2 raised to the power I will be raised. That is 2 raised to the power 1, which becomes 2. And so it will add it to our answer. That is 4 plus 2, 6. And if n is equals to 3, then the minimum element that we can get is 6. And we are going to return 6 in this particular case. So I hope the question is clear to you all. In case the question is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.